Hi, I'm Jessica Diller.
And I'm Ruby Spring.
And we're here to show you our Six's final project video. So on kind of the mechanical aspects of our system, we have this giant tube right here, as you can kind of see as I'm stretching my arm out. And we have attached a speaker to the top with a bunch of tape so it stays steady. And then we have these two wires, which our circuit is going to drive. And then we have this lovely microphone that we're going to be sticking in the end of the tube to record all of our sounds. And as you can see here, it kind of has a pretty snug fit on there.
I'm playing some sounds from my computer. They're gonna go through an inverting amplifier right there. All of our recordings, of course, are going to have some kind of phase shift due to the shape of the tube, but we were wondering if there would be some kind of initial phase shift that would influence the impulse responses. So in order to get the correct phase shift for all the recordings we made, we hooked up our circuit to an analog discovery, and instead of using the nice microphone, we're just using a microphone that can plug into a breadboard and be amplified. And we're scoping both the input to the speakers and the output from the little microphone. And we used one of the super awesome heavy-duty power supplies from the studio, because when we tried to use an analog discovery, we realized the analog discovery could not source enough current for our amplifier to work, for the speaker to actually make any noise at all. And zoomed in super duper close to see if we could see any kind of initial phase shift, and it turned out to be way too negligible for us to take into account. We did some really cool experimental characterization of our tube. We used a gunshot for an impulse response, we ran an exponential chirp, and we did some cool stuff with white noise.
This is Audacity, this is our setup, this is Ruby. She's gonna play all three of them and we're gonna see how they do things. Go, Ruby. As you can see, we have our white noise, our chirp, and our gunshot.
One way we characterized our system was, of course, with an impulse response. And all we did was we took my unloaded flare gun and we made an impulse with the flare gun by shooting it, and we picked up the signal with Audacity on the other end, and you can see the raw impulse response at the bottom. There are some pretty distinct peaks as you go. It's a little unclear as to what sort of function it would be, or how it decays. The second way we characterized our system was with an exponential chirp. As you can see in the top right-hand corner, we ran a Blackman window on our input, which is blue in the graph, so that we wouldn't get aliasing when we took the FFT later on. We ran the input from 20 to 20,000 hertz. And the way you get an approximate impulse response from an exponential chirp is you simply take the FFT of both the input and the output, and you take that output FFT and divide it by that input FFT. You can see our approximate impulse response is the bottom graph. White noise was the final way we characterized the tube. If you take the cross correlation of the input, which is just white noise, and the output, which is also white noise, you actually just get the transfer function over L, which is the number of samples in the original white noise sample, which is the total number of samples in the input. At the bottom, you can see the transfer function from the white noise. The song we chose to take a sample from and filter according to our three transfer functions was called Montanita. And we took the first, 5 seconds or so, and we filtered it. And you can see on the top is Montanita in green after we've filtered it. Blue is before we filtered it for the impulse response experiment. The second. The second graph, the one in the middle, is using the chirp transfer function. The last one is using the white noise transfer function, and you can see for all of them there was definitely a lot of damping. You can not really see much more than that from this. You can actually hear whether or not they really sound like they're coming through a tube, and we can compare them and see which one performed the best experimentally.